4H, product property of exponents. Product property of exponents just says if you take a number raised to a power and multiply it by that same number raised to a different power, that the resulting value will be that same number raised to the sum of those two powers. So essentially, some number a raised to the power m times that same number a raised to the power n is equal to that same number a raised to the power m plus n. So if you have something raised to a certain power with an exponent multiplied by that same thing raised to another power, that you just add those powers together. Well, let's look at an example of that. What if I have 6 cubed times 6 squared? Well, 6 cubed times 6 squared, obviously we can plug that into our calculator, but let's look at what's really happening here. 6 cubed is 6 times 6 times 6, right? 6 squared is 6 times 6. So we've got 6 times 6 times 6 times 6 times 6, right? Which is, so 6 times 6 times 6 times 6 times 6, which, knowing how exponents work, I've got 5 sixes here, so that is equal to 6 to the 5th. Well, what does the product property of exponents says? It says that 6 to the 3rd times 6 squared is equal to 6 to the 3 plus 2, or 6 to the 5th. That's all it's saying. If we realize that any number raised to a power is just that many of that number, or that many of that value, then if we multiply it by that number raised to another power, which that's that many of them, then in total you're going to have this many of them plus that many of them. So if we have 6 to the 3 times 6 to the 2, we're going to have 6 to the 5th. But that's really what it's saying. So let's write some things with a single base, with just one number, kind of like what we did here. 6 cubed plus 6 squared is equal to 6 to the 5th. So now using this, we should be able to write these relatively simply. 8 to the 4th times 8 squared. Same base. 4 plus 2 is 6, so we have 8 to the 6. It's that simple. What if I have 6 cubed plus 6 squared? So can I write that as a single base? Well, that's addition. This is the product property of exponents. No, I can't. I can't write that as a single base. That's where it's left. What if I have 5 cubed times 6 squared? Can I write that as a single base? Well, no. One of the rules of this is that the base has to be the same. We have 5 squared and 6 squared. They're not the same value. 5 cubed and 6 squared. They're not the same value. We can't simplify it. What if I have negative 3 to the 4th times negative 3 to the 7th? Same base, it's multiplication. Add the exponent, so we have negative 3 to the 11th. And that's it. That's the product property of exponents. So let's apply this to scientific notation. I know you don't enjoy scientific notation, but this is something that's going to make it much easier to work with. What if I have 2.3 times 10 to the 4th times 1.8 times 10 to the 5th? So 2.3 times 10 to the 4th times 1.8 times 10 to the 5th. Well, yes, you could turn this into standard form and make that 23000 times 180000. And you could multiply that together. I'm looking at all these zeros and such and going, boy, it's going to take a lot of space and not really accomplish much. So probably not our best method. But we can use the product property of exponents to actually come up with something that is going to be a little more useful. Remember, the commutative property says that we can move around numbers that are being multiplied together and multiply them in any order we want. So why can't I say 2.3, or even the associative property is what I'm going to use here because I'm going to associate certain ones. 2.3 times 1.8 times 10 to the 4th times 10 to the 5th. So I just reassociated and said, well, 2.3 times 1.8, put that over here, 10 to the 4th times 10 to the 5th. Now already you should be looking at this going, aha, I see what he's going to do. We've got two numbers being multiplied together, they're the same base with different exponents. So right away you should be going, oh, well that's going to be 10 to the 4 plus 5 is 9. So that's not bad. And then I need 2.3 times 1.8. Well, 2.3 times 1.8, we can do that multiplication, right? 8 times 3 is 24. 2. 8 times 2 is 16, plus 2 is 18. Put a 0 placeholder in there. 1 times 3 is 3. 1 times 2, we can get that out of the way, is 2. We're going to add those together, gives us 4. 8 plus 3 is 1, carry the 1. 1 plus 1 is 2, plus 2 is 4. And there were 1, 2 decimal places in the numbers we multiplied together, so there's going to be 2 decimal places here. 4.14. 4.14 times 10 to the 9. That really wasn't that painful. If you think about it, it looked really bad there. Oh boy, I've got to do all these things. And then all we had to do was add the exponents and multiply two two-digit numbers, which wasn't bad. I just did that by hand. Okay? Let's do another one because there is a little caveat or something that may come into play. Okay, well what if I do 4.7 times 10 to the 2 times 5.4 times 10 to the 5. So what if I do that? Well, again, I can do the same thing, right? 4.7 times 5.4 times 10 to the 2 times 10 to the 5. And right away you're looking, oh, 10 to the 2, 10 to the 5, that's 10 to the 7. Okay, so we've got that. But now I need to do 4.7 times 5.4. 4.7, 5.4, we multiply. 7 times 4 is 28. 2. 4 times 4 is 16, plus 2 is 18. 0. 5 times 7 is 35. Make that a 3. 5 times 4 is 20, plus 3 is 23. Right? Add together, we get 8. 8 plus 5 is 13. Carry the 1. 1 plus 1 is 2. Plus 3 is 5. 2. And then we had 2 decimal places, so 2 decimal places. So we get 25.38. Woohoo! Okay? We got 25.38 times 10 to the 7. The only problem is that's not scientific notation. It looks like scientific notation, but where's the problem with it? The problem is right here. 25.38. That's our problem. Remember, scientific notation, the numbers are always between 1 and 10. And that's 1 inclusive and 10 exclusive. It can't be 10. You can't have a 2-digit whole part. It has to be a single-digit whole part. This number here in the whole part has to be between 1 and 9. So we have to do one final step in this, that we need to move this decimal point over to the left by 1. Well, if we do that, and turn this into 2.538, well, we just reduced this by a factor of 10, so we need to increase it by a factor of 10, so we get 10 to the 8. Right? It's just like when we're dealing with standard numbers, we turn them into sign notation. If we move the decimal place to the left, then we counted how many places we moved it, and that's what we did to our exponent. We called that the exponent. Here we moved it to the 1, so you could actually say, if I want to break this up a little bit, we moved it over 1 to get it to this, so that's times 10 to the 1. Still have that times 10 to the 7 there, right? So basically, that is this in scientific notation. Then we have 2.538 times 10 to the 1 times 10 to the 7. If I put those together, then 10 to the 1, 10 to the 7, add the exponents, 2.538 times 10 to the 8, and then we're done. So we do need to be careful when we're multiplying or when we're dividing or anytime we're dealing with numbers in scientific notation to make sure that the result of whatever operation we perform is still in scientific notation. If it's not, let's do that modification.